Hot and cold refrigerator. What is this topic?
Is that even a real topic?
Analyze?
Let's discuss about the definition of it.
Hi everyone, my name is Lam Zong Cheng and I am from Xiamen University, Malaysia. This video will be all about me and my group mates who will be introducing themselves in the next few seconds. We will be talking about a very real topic, which is hot and cold refrigerator.
Hello everyone, my name is Matthew Engkai Hong and I am a student of Xiamen University, Malaysia.
Hi everyone, I'm Wei Jun. I'm a student from Xiamen University, Malaysia.
My name is Wang Yaozhi, and I am the student of Xiamen University Foundation.
Before we talk about the topic, let me show you all the table of contents. Here are all the topics we are going to talk about later on. The first one will be the definition, and then the second one will be the vapor compression, and the third one will be second thermodynamic, and the last one will be the vapor absorption system. Let me introduce to you the definition of refrigerator. I would like to show some videos of the refrigerator in my house so you all can understand it better. So this one is the most common refrigerator which I believe everyone has one in their own house. And there's actually another kind of refrigerator which is this one. And they both function in the same way, but this one is a bit more effective, as you can see a layer of ice right there. If you go and place your hand behind an operating refrigerator, you will notice that this area is warmer than the room temperature. Or you might even notice that the refrigerator blows the warm air on your feet and as you stand in front of it. Yet the interior of freezing compartment is very cold. What it means? That means the refrigerator is taking the energy from the freezing compartment, making it colder, and then exhausts that heat energy to the surrounding. Refrigerator is a heat engine in which work is done on a refrigerant substance in order to collect energy from a cold region and then exhaust it in a higher temperature region, thereby further cooling the cold region. The term refrigerator was coined by a Maryland engineer, Thomas Moore, in 18,000. Moore's device will now be called as an iBox, which is this one. Yeah.
Now, I'm going to talk about the vapor compression cycle. The vapor compression cycle is used by many refrigeration, air conditioning and other cooling applications. The most common one is the refrigerator of our house. Before knowing how it works, let's learn about the main component of the cycle, and I will explain this by using the refrigerator of my house.
阿伯，你在做什么？
没有啦，我在拍 video 啊，这是学校 assignment 要用的。等下我要用我们家的冰箱来解释一下。
喂，你不要跟我乱啊！不要拿我们家冰箱来搞七搞八哦，等下弄坏哦，我跟你讲哦。
不会的啦，来，我跟你解释一下我要怎样用啊，来，走。
2,000 years later.
Guys, I'm so sorry. Due to some technical problem, I can't use the refrigerator of my house to explain the vapor compression cycle. So, I will use some picture as the replacement. Hope you all can enjoy it. First of all, the compressor. Its job is to circulate refrigerant throughout the system, adding pressure to the warm area of the circuit and heat up the refrigerant. You can think of it as the heart of the refrigerator. Next, the condenser. Its function is to cool down the hot refrigerant by spreading the heat to the surrounding. Furthermore, the expansion valve. It is a device that regulates the flow of liquid refrigerant into the evaporators. Last but not least, the evaporator. It evaporates the refrigerant to make the area inside the refrigerator becomes cool. Now, I will explain how the vapor compression cycle works. Firstly, the refrigerant enters the compressor as a low pressure and low temperature status, where the pressure is increased and it leaves as a higher pressure and higher temperature status. Next, This hot pressurized refrigerant then passes through the condenser where it releases heat to the surrounding as it cools and condenses completely. After that, the cooler high-pressure refrigerant next passes through the expansion valve, which reduces the pressure abruptly, causing the temperature to drop dramatically. Lastly, the cold low-pressure refrigerant next passes through the evaporators, where it vaporizes completely as it accepts heat from the surrounding before returning to the compressor as a low pressure and low temperature status to start the cycle again.
Once on the physc2 on thermodynamics, second law on thermodynamics said that heat will naturally from an object at a higher temperature to an object at a lower temperature, and heat does not grow in the opposite direction of the own accord. This theory means heat will always from high temperature to low temperatures. Heat will not grow from low temperature to high temperature, otherwise it is wrong. For example, let's say this is the lake in the high mountain, and the water will always flow from high mountain to the sea. This is the same concept of the second law of thermodynamics. And you see, this is a 2 glass of water. Now this glass of water, they represent the land in high mountain, and this glass represent the sea. Now, and I just mentioned that water will always from high mountain to the sea. Sound like this? This is a water flow from high mountain to the sea. Let me read two examples. Air conditioner is based on the theory of the second thermodynamic theory. Air conditioner used to cool the environment and move the heat from the interior to the outdoors. Therefore, a refrigerator moves the heat from the ice blocks in the refrigerator to outside of refrigerator, also the second thermodynamic theory. This is the like vapor absorption, vapor conversion was based on the theory of the second thermodynamic theory. This is done to produce the cooling effect and remove the heat out of the atmosphere.
2 hours later.
So now, I would like to talk about vapor absorption cycle. In the vapor absorption cycle, the process of suction and compression are carried out by two different devices called as absorber and the generator. Thus, the absorber and the generator replace the compressor in the vapor absorption cycle. In the early years of the 20th century, the vapor absorption cycle using water ammonia system was popular and widely used, but after the development of the vapor conversion cycle, it lost much of its importance because of its low coefficient and low performance. Nowadays, the vapor absorption cycle is used only where heat is more readily available than electricity, such as industrial waste heat, solar thermal energy by solar collectors, or off-the-grid refrigeration in the recreational vehicles. In an absorption refrigerator, a suitable combination of refrigerant and absorbent is used. The most common combination are ammonia and water and lithium bromide. That's all.
In conclusion, refrigerator is one of the inventions that had a significant impact on our life. It had enabled everyone to store their food for several days or even several months. it can be said that this invention had promoted the progress of the time. And this will be the end of our video. Thank you for watching.